Good day, guys. You are welcome back to ID International Academy Mathematics class. Before we go into today's work, let's have the solution of our last class assignment. The question number 1 in the assignment is on the board. Simplify 3 raised to the power 3x minus 1 times 9 raised to the power 2x plus 1 times 27 raised to the power minus x divided by 81 raised to the power x. To simplify this, we have 3 raised to the power 3x minus 1 times 3 raised to the power 2 into 2x plus 1 times 3 raised to the power 3 into minus x divided by 3 raised to the power 4 into x. This division sign is what I use to represent the division line here. Do we understand? So, we go as 3 raised to the power 3x minus 1 plus this multiplication changes to addition in the exponential area. So, plus 4x plus 2. I open this bracket. This multiplication also changes to addition in the exponential region. So, plus minus 3x. 3 times minus x, that's minus 3x. I bracket it. This division changes to subtraction in the exponential region. That is minus 4x. So we have 3 raised to the power 3x plus 4x, that is 7x. Minus 1 plus 2, that is plus 1. Plus times minus, that is minus 3x minus 4x. Looking into that very well, 3 raised to the power 7x plus 1 minus 3x minus 4x is minus 7x. So 7x minus 7x gives 0. So we have 3 raised to the power 0 plus 1. 0 plus 1 is 1, so 3 raised to the power 1 is what we have. Don't forget 3 raised to the power 1 is 3. And that is the end of question 1 in the assignment. Question 2 in the assignment is simplify y raised to the power 3 times y raised to the power 2 divided by y raised to the power minus 7, or in bracket raised to the power half. So we begin by simplifying the element inside the bracket. So we have y raised to the power 3 plus 2 plus 7 raised to the power half. Are you confused? What we do here is this. The relationship between this and this is multiplication. So that multiplication sign will change to addition in the exponential region. And that is this addition sign, this one. This division line is normal division. So that makes the power negative 7 to change to positive here. Because division will change to subtraction there. And negative times negative 7 gives positive 7. And that is why that is like that. So we have y raised to the power 12 times half. See the way I write it now. Whether I write it like this or like this is the same. So half times 12, that's 6. Y raised to the power 6. That's the final answer to that. Question 3 of the assignment. 2 times 8 raised to the power x over 3 plus 1 minus 2 raised to the power x plus 2 divided by 2 raised to the power x minus 1. So we have 2 times 2 raised to the power 3 into x over 3 plus 1 minus 2 raised to the power x times 2 raised to the power 2 divided by 2 raised to the power x divided by 2 raised to the power 1. Are we following? So this simply means 2 times 2 raised to the power x plus 3 minus 4 into 2 raised to the power x divided by 2 raised to power x over 2. Looking at this critically, by the time we use this 3 that is outside the bracket to open the bracket, what do we have? We have x plus 3. How? 3 times x over 3. We have 3 times x over 3. This 3 will take care of 3. We have x left. Now, plus 3 times 1, 3. That is why we have this. I want to believe it is clear now. Now, this is 2 raised to power 2, which is 4. 4 times 2 raised to power x, we have this. So, rewriting this as 2 times 2 raised to power x times 2 raised to power 3 minus 4 into 2 raised to power x divided by half into 2 raised to power x. 2 raised to power x over 2 could be written as half of 2 raised to power x. Know that. Now, 2 raised to power x plus 3 could be reversed as 2 raised to power x times 2 raised to power 3. This is a reversal of what is above here. So 2 raised to power 3 is 8. 8 times 2 is 16. 16 times 2 raised to power x, that is 16 into 2 raised to power x minus 4 into 2 raised to power x divided by half into 2 raised to power x. 16 into 2 raised to power x minus 4 into 2 raised to power x gives us 12 into 2 raised to power x divided by half of 2 raised to power x. Are we following? Good. Here now you can see conspicuously that 2 raised to power x will be divided by 2 raised to power x here, leaving behind 12 divided by half, which is 12 times 2 by reversal, and answer is 24. That is the end of question 3 of the assignment. Let's see the last question in the assignment. Simplify 2 raised to power x times 3 raised to power x times 6 raised to power x in the form m raised to power 2x. Hence, find them. So what do? By now you must have known that in indices, once the powers are the same in an indical expression, then the base can be multiplied together. That is, 2 raised to power x times 3 raised to power x times 6 raised to power x could be 2 times 3 times 6 all raised to power x, which means 2 times 3, 6. 6 times 6, 36 raised to power x. So you now think of expressing 36 in index form. So it will be 6 raised to power 2 into x, which is 6 raised to power 2x. So it is now in the form of m raised to power 2x, since 6 raised to power 2x is in the form of m raised to power 2x, then m equals 6. Do you understand? Just compare, by comparison. 6 raised to power 2x is in the form m raised to power 2x. Power 2x here is the same thing as power 2x there. The base 6 here must be the base 6 here, meaning that m is equal to 6. That is the end of the solution of the assignment. You can now move on to today's topic. Now today, we are moving to the new subtype 2 under the topic indices. We want to explore the word of exponential equation 1. Why do I call it 1? After this, we still move a bit higher under exponential equation. That's why I call it 1. Now, laws of exponential equations are what we are going to address first in learning how to approach indical equation. That is the equation in indices form. Law 1 is the law of common base in equation. That when we have indica equation of only two terms, such that one term is on one side of the equation, the other term is on this other side of the equation, and the bases on both sides are equal. What's the implication? The implication is that the powers also are equal. If we have 5 raised to power x, which is equal to 25, we express it as 5 raised to power x is equal to 5 raised to power 2. You can see now that we have indica equation of two terms, such that each term is on either side. And the bases on both sides are equal. The fact that the bases on both sides are equal makes their powers also to be equal. You see, therefore, x is equal to 2. Equal bases means equal power. That is a law. How do we make use of the law? Example 1. If you have a question like solve 2 times 4, are you with me? 2 times 4 raised to power x plus 1 equal half. If you are given something like this to tackle, so you express it as 2 raised to power 1 times 2 raised to power 2 into x plus 1 equals 2 raised to power minus 1. So applying the normal law of indices, law of multiplication, you rewrite this as 2 raised to power 1 plus, opening this bracket, 2x plus 2. The first addition sign here is as a result of the multiplication symbol changing to addition symbol in the exponential region, so which is equal to 2 raised to power minus 1. Now here we come to the law point. You can see now that this equation is exactly in the format of what we have here in the law 1, such that the common base here suggests that their powers also are equal. That is, 1 plus 2, which is 3, you write 2x plus 3 is exactly equal to minus 1. We now solve this equation with form. Why do we conclude that 2x plus 3 is equal to minus 1? Because 2x plus 3 is a power on this side, and minus 1 is the power on the other side, and the power on both sides must be the same, so far their bases are the same. That's why we equate them to each other. So solving the equation, we have 2x equals minus 1 minus 3. Are you following? We are solving this equation. You have 2x equals minus 1 minus 3. So we have 2x equals minus 4. Dividing both sides by 2, the coefficient of x, so we have 2x divided by 2 equals minus 4 divided by 2. X now is equal to minus 2. That is the end of that example 1 under the law 1. Law 2 in the indica equation or exponential equation, you can call it in either way. Law 2 states that if you have common power on different sides of the equation, simply suggests that their root numbers are also the same. As you can see, x raised to power a is equal to 3 raised to power a. The power on this side, which is a, is equal to the power on the other side, which is a. Definitely, their base numbers are the same. This base number here is x, the base number here is 3, then their base number are the same. Thus, x is equal to 3. So let's see example to that. Example 2. If p raised to power 6 is equal to 64, find p. What do you do? Simply remember that p raised to power 6 is an index form. So try to express 64 also in index form. So you have p raised to power 6 is equal to, now at this juncture, remember 64 could be expressed in index form in 3 different ways. As 2 raised to power 6, or as 4 raised to power 3, or as 8 raised to power 2. So you have to be very smart to know the one that suits each situation. So at this level, I use 2 raised to power 6 because I have a target. If I use 4 raised to power 3, it will not suit my target in this case. So I use p raised to power 6 is equal to 2 raised to power 6. Since the powers are the same on both sides, so therefore p is equal to 2. That is, the base numbers are also the same. Simple. That is the application of this law. So let's move on to the next.